We have a calculator free question, which is asking us, how do we differentiate tan of x? How do we do that? And then also later on, we'll use that answer to figure out part B. So let's start off with, how do we differentiate tan of x? So tan of x is equal to our opposite over our adjacent. Okay, and so now the question becomes, how do you differentiate this? And we can see it's one function divided by another function. Now you can decide to use your chain rule, but I always much prefer to use my product rule when given the opportunity. So this is actually equal to sine times by cos all to the -1, and this converts it into the product rule. So let's call the guy on the left f and the guy on the right g. Okay, so if we're wanting to find um, the differential, this is equal to f g plus f g, put a tick on the f, put a tick on the g, and now let's write a table out so that we can substitute it in and it'll make our lives easier later on. So first of all, the f is equal to sine x, and that differentiated, all right, is equal to cos. Okay, so you need to know when to put a negative sign and when not to. I have a little acronym and I say that DC Comics is worse than Marvel. Okay, so if you differentiate cos, it ends up with a negative. So if you have something like d dx of cos, so you differentiate cos, that'll give you a minus sign. And a minus sign and also a sign as well, just to be confusing. Whereas if you integrate sine, you will end up with a minus cos. And that's the easiest way that I like to remember it. So then I integrate that and I get a cos. So now that we know that, we can say that when we differentiate sine, it doesn't actually give us a negative. However, g is equal to cos minus 1 of x, and then g prime this time would be equal to, all right, now we have to understand that this is like saying 1 divided by, like 1 divided by cos x. So in this case, we get, it becomes the inside of the brackets stays the same, and that becomes that minus 2. I'm going to write this down the bottom elsewhere because I am running out of space. But we also times by the guts of it being cos inside the bracket, and that becomes a minus sine of x. And we've also multiplied by that minus 1. So I'm going to write g of x again to make it a lot easier because there's a lot going on there. So g prime is equal to the minus 1 from that it's like been raised to the power of minus 1 with a minus sign. And then now we've got our cos x, and that is to the power of -2. So those guys cancel out, and now we can just start substituting in. So let's do it. Let's substitute everything into these equations here. So it would help if I make it color coded. So the f is over here, the f prime is over here, the g goes over here, and finally the g prime goes over here. So I'm going to go ahead and I'm going to substitute everything in now. So we can say that d dx is equal to, I'll just say it's a y to make life a bit easier. Okay, so now the very first bit, that f prime, which is cos x. Okay, and then we have our g, which is cos x minus 1. And another way of writing that is like this. Okay, and then I'm going to run out of space, so I'll put a plus, and we'll get our f, which is sine of x. And we also have our g here, okay, and that g prime, and that's this horrible looking thing over here. So let's multiply it all together. Okay, and then we also have this cos x minus 2. So we can write this a little bit easier. So let's simplify it. But for the purposes of this, it's only 2 marks. The above is your final answer. Simplifying it does make it easier for the next part of the question. So we've got this, which we know as being equal to 1 plus sine. I'll put everything in brackets because I think it makes it easier to understand. So we've got the squared, and then we can drop this one below because it's that minus sign at the top. So if you have something like 3 to the minus 1, that's equal to 1/3. Okay, so just so you've got that there. And then we can say this is all equal to cos x squared. So therefore, we can say all of this is equal to 1, because they cancel out, plus, now I'm going to do something funky here. I'm going to say is equal to tan squared. How did I get that? Well, because it's the sine divided by our cos times by sine divided by our cos. So hopefully that makes it easy to see. Okay, so this is now equal to tan, and I can draw the little 2 there. And as you know, that's basically the same as saying like a big square brackets around there and putting a square there. Okay, so that's part A done. Let's get to part B. Part B, in this case, is asking us to find a horrible equation here, and that is pi on 6, pi on 4, and cos minus 2x. Now, I can actually go one step further here, and I can change this 1 plus tan business. All right, this 1 plus tan business, this can be transformed into cos negative 2x. Okay, I'll show you how. So this is the key, this is the trick here, really. So if you, we can say that in this case here, it's going to be cos, uh, so in this case, we're going to convert 1 plus tan. Okay, I'm going to do another step and convert this again. That is like saying, so 1 divided by 1, instead of writing it like that, I can write it as cos squared divided by cos, oh, got a bit funky there, cos squared. And then plus our sine, all divided by our cos. Okay, so what I can do is if I have 1/2 plus 2 on 2, that can be join up the bottom bit, so it becomes 1 plus 2. So that's what we're going to do here. We see that the bottom bit is the cos squared, and we join them up. And so that is all equal to cos squared x on cos squared x plus sine squared x. Now, here's the trigger. This is equal to 1 this whole thing here in pink. This is a trig identity. So it's, I believe, it's in your formula sheet. So if you go down, nope, not in your formula sheet, but in this case here, it will be equal to 1. So this will be given as a hint in the question. So this will all be equal to 1 on cos squared x, which is like saying cos minus 2x. And that is the very same thing as our value at the top here. So because we went and we did all of that, we said that cos minus 2x is equal to the differential of, all the way at the top, it's equal to this. So this here is equal to cos minus 2x. Okay? That means that you can then use it so that when you integrate it, that this is equal to tan straight away. So you have to use your answer from the previous part. Okay, so that's what we're going to do here. So use answer from part A, and we can say that this integral from pi on 6 to pi on 4 of cos minus 2x dx is equal to tan of x. And then we can put everything at the top here. So this is our definite integral. So now we substitute the top and minus the bottom. So we're going to put in tan pi on 4 minus by tan pi on 6. Okay, so now that we've got that, we have to remember our exact values. Okay, so I like to draw a table. All right, so if you don't know your exact values, I really like to draw a table here. And so we start off with 30 degrees, or 0, so 0, and 30 degrees, which is pi on 6. So pi is 180 degrees, so 180 divided by 6 is 30 degrees. Then we go to 45 degrees, which is our pi on 4. And then we go pi on 3, 60 degrees, and then pi on 2, which is our 90 degrees. So after doing all of that, we start off with our sine, and if we draw our unit circle, we get that sine of 0 is equal to 0. Sine of 30 degrees is always equal to, remember, divide by 2 here, and we're going to put a square root around everything. Okay, and then this one here is 1, because 90 degrees up here is sine is, you got to crawl before you can touch the sky. So sine is touching the sky, and that's the coordinate 0 and 1. So that's why we get the value 1 there. And we can say it's 1, 2, 3. So we do the same thing with cos, except we reverse it. We start off with 1, and we divide everything by 2. We have our square roots there. But this time, we go back from 3. So 3, 2, 1. And then finally, to figure out tan for the exact value, is it's always tan is equal to, remember, like so, ka, toa. So as our opposite divided by our adjacent, opposite is going to be sine, our adjacent is going to be cos. So in this case, it's going to be 0. And then we can see that we can replace it here as root 3 to the power root 3, and then root 3. And we go minus 1, 0. Oh, And we don't know what it is at infinity, but we can say this is -1, 0, and 1. So the two things that we're interested in are these things in green here. We're interested in these ones. So what we can say is that tan of pi on 6, aka 30 degrees, so tan of pi on 6, let me draw that again, that's horrible. That is equal to root 3 minus 1, which is 1 on root 3. Okay, and then you might have seen it where they times by 1, but not just any 1, it is root 3 on root 3. So another way to represent that is by saying root 3 on 3. And if we have tan of 45 degrees, well, that is equal to root 3 to the power of 0. Put that in your calculator right now. I know it's a non-calc question, but put it in your calculator. See what you come up with. It's going to be equal to 1. What happens if we put 30 to the power of 0? It's also equal to 1. Anything to the power of 0 is equal to 1. So let's substitute in back into our original equation, which was saying that tan of pi on 4 minus pi tan of pi on 6, that is equal to, and then you can just write it in as 1 minus root 3 on 3. Now in maths, there's a thing that we don't like to put the square root underneath. We don't like to divide by square roots, so let's put it on the top like this. And that's how you do it. There's lots of other questions like this on my website. You can find it in the description below. If you have any questions, reach out, leave a comment, give me a like. I'd be happy to help.